Hi, this is a quick tutorial on Working Model 2D. This product allows me to see what's going to happen with King Arthur um, during a throw. On this particular one, I have a counterweight, and that counterweight is actually on this slider, so I can change what it is um, just by using the slider. Um, Now, the other thing I want to be able to change is when the counterweight arm and the actual throwing arm, which is the red part, gets to a certain angle, it'll actually release a pin down here which allows the throwing arm to go through. Let me go through the thing once first, and I'll show you what happens. So the arm is coming down, it finally releases, it allows the throwing arm to go through. The sling allows the pumpkin to essentially be released at a certain point. Now, where that pumpkin gets released is actually another angle between the sling and the throwing arm, and that's represented down here. So I can change that at will also. So I can I have the mass of the pumpkin also being displayed here as being 9 pounds. The pumpkin is traveling at 173 miles per hour. So that's a velocity that I'm picking up off the pumpkin. If you'll notice, the arm, the counterweight arm, is actually going through the 90-degree position, and it's still pulling, but you can see it's slowing down at this point. If I continue a little further, you see it's almost stopped. So I've done a pretty good job of getting that that energy transferred to the pumpkin. Now, what I've done here is I've changed that angle between the throwing arm and the counterweight arm to 80 degrees. So it's going to release a lot sooner down here than it did before. Let's see what the effect is. So as it comes down, there it released. And you'll notice that now the counterweight arm is directly underneath the axle. And also you'll notice the fact that this arm didn't get all the way through the way it did before. So it didn't pull all the way through. And the release at this point is going a lot higher. And the speed of it is only 141 miles an hour. So this is the kind of tool that I use to determine things like when should I release the throwing arm, when should I release the pumpkin, what happens if I take the weight, for example, and let me send this back to 105, and I'm going to change the counterweight now to 880, and let's see what happens. So as it comes through and finally releases, now the pumpkin, instead of going 170, is now going up to a little over 200 miles an hour. Okay, so changing the counterweight, for example, has a big effect. Now the other question I've got is, what effect does this have, for example, on the amount of pressure that I have to hold on the axle? So let's take a look at this. There's my axle right there, and I'm going to measure the amount of force on that axle. As a matter of fact, what we're going to do is change that so I can see it like that, and I'm going to go zooming back out again. And let's go ahead and run the model. Okay, now this has the X and Y components, which are important in some cases. In this case, what I'm looking for is the total force. So let me back this off and see what the actual total force that I have to manage to. Okay, there's the peak right there, and the actual number of the force is 7,600 pounds. So I have to manage a force of almost 8,000 pounds on this axle. Okay, so I have to design the axle to be able to manage to those kinds of forces. This becomes an important tool. From here, I usually transfer this into an AutoCAD drawing so I can see what is going on in 3D, and I can turn it around and look at it from different positions and make sure that everything flows and everything fits. Then I can go ahead and start building. So I already have King Arthur built, so essentially what I'm doing is making tweaks. And that's one of the reasons why this model turns out to be such an important thing for me. Thank you for listening, and that's all I got for that.